Aldrich, and this is my curriculum analysis of Ohio mathematics education, particularly the algebra content area for high school. Today we will be looking at 5 sections of this, including the foundational elements, the organizational elements, content elements, assessment elements, and critique elements. The first element is the foundation elements. In here, I'm going to consider what does the advisory or writing group include, how legitimate is the document, and has it been adopted elsewhere, how credible are the developers, and what is the stated purpose of the organization. During the summer and fall of 2010, the Ohio Department of Education sponsored regional teacher team meetings around the state to collect ideas for the instructional strategies and resources section of the model curriculum. More than 500 teachers from across the state provided insight and expertise that has been incorporated into the model curriculum. ODE is working on future methods for collection and submission of ideas to be considered for the model curriculum. When it comes to how legitimate the document is, legitimacy is gained when other places implement the same process. In 2010, the Common Core State Standards were released. Ohio adopted these Common Core Standards in June of 2010, along with Ohio's own standards in science and social studies. By late 2011, Common Core adopted 42 states and the District of Columbia into using this model. Although the Ohio Department of Education has implemented the standards were created by the National Council of Teachers of Mathematics, and so they were founded in 1920. They're actually the world's largest mathematics education organization, and they have 80,000 plus members. In 1989, they released these standards, and then in the early 90s, states developed standards in various subjects. When No Child Left Behind came out in 2001, they required state standards and assessments in English language arts, mathematics, and later in science. During the 2000s, the state standards were shallow and repetitive. They varied widely in quality, rigor, and topics, and they were not preparing students for college and careers. Most careers actually require some post-secondary training, and not enough progress was shown compared to our international peers. In 2007, governors and state superintendents began discussing shared standards across interested states. In 2009, the Common Core State Standards Initiative launched, and 48 states participated in the development of the standards in mathematics. It was a very broad and bipartisan effort on all counts. The mission of the National Council of Teachers of Mathematics is the public voice of mathematics education, supporting teachers to ensure equitable mathematics learning of the highest quality for each and every student through vision, leadership, professional development, and research. Their vision is to be the global leader and foremost authority in mathematics education, ensuring that each and every student has access to the highest quality mathematics teaching and learning. We envision, we being the National Council of Teachers in Mathematics, envision a world where everyone is enthused about mathematics, sees the value and beauty of mathematics, and is empowered by the opportunities that mathematics affords. The second section is organizational elements of the high school math curriculum. The ideas considered in this section are the presence of stated goals, identifiable sources of curriculum design, what is the curriculum design type, are there design principles present, how is the subject matter organized and sequenced. When these standards were developed, the researchers created 8 practices they wanted students to be able to attain. They wanted students to make sense of problems and persevere in solving them, to reason abstractly and quantitatively, construct viable arguments and critique the reasoning of others, model with mathematics, which is word problems, use appropriate tools strategically, attend precision, look for and make use of structure, look for and express regularity and repeated reasoning. Now each of these has bullets underneath it that the researchers wanted them to be able to do. For example, when talking about making sense of problems and persevere in solving them, an example would be for students to explain to themselves the meaning of a problem and looking for entry points to its solution. When it comes to reasoning abstractly and quantitatively, mathematically proficient students will know and flexibly use different properties of operations and objects. The third goal, constructing viable arguments and critique the reasoning of others. The proficient students understand and use stated assumptions, definitions, and previously established results in constructing arguments. They have different categories for each of these that show what it means for a student to be proficient in mathematics. The second topic is identifiable sources of curriculum design. When constructing this, there were three different focuses of the curriculum design. The first was focus itself, which includes identifying key areas, understandings, and skills for each grade or course, then stressing deep understanding and learning, which means applying the concepts and skills within the same grade or course. Coherence is defined as the progressions of learning within and across grades. So the researchers wanted the students to be competent from grade to grade and to use different techniques in each of the grades. They also wanted concepts and skills that are developed over a defined period of time. When it came to rigor, the standards highlight conceptual understanding, procedural skill and fluency, and application. The researchers did not want the students to slack when it came to what they were learning. When it comes to the curriculum design type, there are 5 components of that. The subject, which here I'm looking at Algebra 1, societal activities and problems, so how each of those things affects what is being learned. Specific competencies in their performance, so there are benchmarks that the state wants students to be able to obtain. The individual needs and interests needs to be met in order for the students to find the material relevant, and then also to complete it willingly and well. Then, in order finally to do this, they need to have process skills. So they can't just go in and do it by themselves. They need to learn skills in order to solve these techniques. Some of the design principles that are present are breadth, progression, depth, relevance, and coherence. So each of these are important. When they were originally narrowing this down, they thought of the mathematics curriculum as a mile wide and an inch deep. And so we will go into this a little bit later, particularly breadth and depth. But for right now, that's all. When the subject matter is looked at as organized in sequence, there are 6 different themes that the researchers and developers created for high schoolers. Number and quantity, algebra, functions, modeling, geometry, statistics, and probability. Now, each of these things goes into more depth. So some topics in each category are indicated only for students intending to take more advanced optional courses. So Ohio State standards only require that you take 4 units, right? And Algebra 1 is the first of those 4, and you need to pass an Algebra 2 equivalency. Now, each of these courses goes into a number of the different themes. So you start off a little bit wider, just as it shows in that picture, and then you get narrower as you obtain further and further information. Our third section is content elements. The things we're going to consider in this are, do the learning content objectives reflect domains? What is the level of content complexity? And what are the instructional time guidelines? Is there evidence of career opportunities and applications to real life? Does the course of study stress substantive knowledge or syntactic knowledge? Is the curriculum relevant to the learner, and is there authentic learning? And are teaching strategies indicated or suggested? Do the learning content objectives reflect the domains? When looking at the algebra, there are 4 different domains that they go into. Scene structure and expressions, arithmetic with polynomials and rational expressions, creating equations, and reasoning with equations and inequalities. Each of these 4 domains have numerous objectives, which come in the form of standards. Some have 7, Others have as few as 2. When it comes to the level of complexity in instructional time guidelines, the Ohio Department of Education has created a model curriculum. And so the content complexity, Algebra 1 is not very complex because it's earlier on in the high school career, and it uses all of these broad bases that were formed through the previous years. When it comes to pacing, they show you how fast you should be moving from standard and domain to domain. When it comes to evidence of career opportunities and applications to real life, there aren't very many opportunities to do this in real life. That's what the research shows. However, most people use day-to-day mathematics, which includes algebra. So here you can see in the chart that it says that 19% of people use algebra in their career paths. However, it's not always that much in some of the other careers. But you will always be using math, and so the foundations that you build within these projects, within this curriculum, will really help you in developing yourself as a lifelong learner, and as well as helping you in your career in some way, shape, or form. When it comes to substantive or syntactic knowledge, really, the Ohio Department of Education stresses the substantive. So they rely on central concepts, organizing principles, and factual data. There's not a lot of room for inquiry, discovering, or rearranging knowledge to make new interpretations. Ideally, there would be, but because of the tests that the Ohio Department of Education has put into practice, there's not enough time for the students to really go into syntactic knowledge. When it comes to relevancy to the learner, you really need to find what they're interested in what you say. That's really the key of relevance. And so in order to have authentic learning, you need to have relevance. This comes in the form of the modeling, which is a huge emphasis of the Ohio Department of Education. Modeling is really just different word problems, and so they create word problems for you to use. You make your own as well, so that way it becomes relevant to the students and they can see these real-world applications. Again, the teaching strategies are indicated and suggested within the model curriculum. They give you suggestions because they want you to succeed, they want your students to succeed. Our fourth section is assessment elements. So there are 5 different ideas considered, including the means of assessment. Is there an orientation of the assessment to the learning objectives? Is the assessment summative or formative? Is there evidence of rubrics? Are there suggested teaching strategies? So the first one, the Ohio Department of Education actually tests students from 3rd grade to 10th grade in mathematics. They want to see how the student is progressing and evaluate them at each stage along the way. Algebra 1 is typically taken in 9th grade, but it's given up to the schools, and they have a choice of when they want to have their students take the AIR test for Algebra 1. In terms of an orientation of the assessment to the learning objectives, each test is given a practice test with a rubric, and they answer how each question addresses certain standards. And so you can tell as a teacher which one they care about more, so you can practice more of that type of problem in your curriculum. The assessment is really a little bit of both, summative and formative. So summative assessments is evaluating the student learning, which they do from the 3rd grade to the 10th grade. And the goals, the formative assessments are goals to monitor student learning. So they do it each year to see how the student is progressing. When it comes to evidence of rubrics, again, there's a scoring guide and a practice test that the students are able to take and the teachers are able to teach from, so that way the students are more prepared for the assessment. There are suggested teaching strategies, as mentioned earlier, because each domain has a model curriculum that gives instructional strategies on how to teach the content. The last element is the critique elements. There are only 5 ideas considered, including scope, sequence, spiral, and continuity, the learning activities and experiences, how much of a foundation is given, if there is evidence of subject isolation or integration, and the content selected for substance or process. So for the scope, sequence, or spiral discernible, Scope is really the depth and breadth of the content. Sequence is the order that the content is taught. Spiraling is the same topics growing in complexity each time the students see it. And continuity is how previous and future learnings relate. And so the mathematics is really important with spiraling. As seen earlier, you start off a little bit wider, and as you move forward, you narrow your focus. In the scope, the depth and breadth of the content is really important. You can see it in this chart here, how it progresses from kindergarten all the way to high school. And so there are the 5 different sections, the 5 different themes in high school that they go into through the various courses. For learning activities and experiences, there really are a lot of activities that the students are able to do with the different various experiences in the curriculum. And that really comes from the modeling of the curriculum and the word problems that are associated with it. In terms of time spent on developing a foundation, mathematics is the most important foundation to have, and so there really isn't enough time spent on developing the foundation, as the depth with which the state wants you to go, especially in Algebra 1 and beyond, is so deep that you really need a broad foundation for the structure to be stable, for the learning to be stable. There's a lot of isolation, more so in the high school subjects, but in the younger grades, the subject integration is huge. So you have all these different themes that are playing out in the course of one topic. However, when you get to high school, they start isolating it a bit more. In Algebra 1, it's still pretty integrated. You see a lot of the 5 different themes within it, and you see that throughout. When it comes to if the content selected is for substance or process, the choice is really given to the school. Our school really focuses on the process, and so you spend a lot of time on the foundation and not so much on the substance, as we're looking for the students to pass, and so we need that broad foundation to include enough for especially our students, which are riddled with poverty. So we need that broad foundation. So our school focuses on the process more than the substance at first. When they get to the older grades, they focus more on the substance. Thank you for listening to my presentation. These are the various references that I used in this presentation. I hope that it was to your enjoyment and that you had a fun time as much as I did.